Good morning. Today we're going to look at section 6.2. We're going to focus specifically on the disk and washer method for volumes of revolutions. All right, I've got 3 examples again today. First example is calculate the volume of a solid obtained by rotating the region formed by the following equations. I have the graph drawn here. We're going to go from x equals 0 to 2. Sorry about that. So we're going to go from 0 to 2, just sketching on our picture here. We're going to rotate this around y equals 0, which is the x-axis. So here's our curve. We're going to rotate it around this way. This is going to be a disk method problem. We know that A here is going to be 0, B is equal to 2, and so our volume is going to be pi integral from 0 to 2 of x squared dx. And then once you work that out, you're going to get 32 over 5 pi. That's a pi. Sorry, I almost made that an x. So that's a disk method problem. Starting at 0, going to 2. Okay. All right, our next example, we want to find the volume of a solid revolving it between the following regions. So we're going to go from, looks like x is going from 1 to 3. And we've got f of x is x squared plus 4. G of x is just 2. So this blue line on the graph, that's going to be g of x, horizontal line. And then the red curve, that's going to be our top curve. And we're going to go from 1 to 3. And we're going to rotate this around the x-axis. So this is the region that we're dealing with. And now we want to draw our rectangles, our big R and our little r. This rectangle here is big R. This rectangle here is going to be little r. And again, we're going to rotate it around the x-axis. So A is clearly 1, B is clearly 3, and the volume is going to be pi integral from 1 to 3 of big R. Oh, I should note, what is big R? Well, big R is the distance from the top of this rectangle to the bottom of the rectangle. So big R in this case is just x squared plus 4. And little r is this top rectangle minus the bottom. So this is just going to be 2. So our integral here is going to be pi 1 to 3 of big R squared minus little r squared dx, and that answer is 2,126 over 15 pi. So I'm giving you the exact answers here, so in case you want to actually try to work those out by hand. All right. The third and final example here, I didn't give you a picture on this one. It says find the volume obtained by revolving the regions between y1 and y2 about the line y equals -3. So let me first start off by sketching this. Let's do black. So we've got the x-axis and the y-axis. Both curves are parabolas. Let's do blue here. So the y1 curve is something maybe like this, so that's y1. And then the y2 curve, I'll do green. So the y-intercept there is 4, and it's going to be opening down, so it's going to look something like this. And so our region is this stuff here in the middle. We're going to rotate this around the line y equals 3. So instead of the x-axis, we're actually going to rotate this guy down here around the line y equals -3. Okay, so how are we going to do that? So we're going to rotate it around this guy. We need to draw our representative rectangles. Let's do that in, I guess, kind of dark blue. This right here is going to be big R, and big R here is going to be the green curve, which I believe was y2. This was y2. So it's going to be y2 minus -3. In other words, it's going to be y2 plus 3. And then little r is going to be this rectangle. Little r is going to be y1 plus 3. So I would assume that you could plug these into your calculator, or you can work these out by hand. So our volume is going to be pi integral. I'm actually going to do a little bit of a trick here. And I'll let you hopefully figure out why I'm doing this. But instead of going from -1 to 1, and I should have mentioned that earlier, that this is x equals -1, and this intersection point here turns out to be x is equal to +1. I'm only going to go from 0 to 1. And instead of going from -1 to 1, since I'm doing that, I'm going to do times 2. And the reason I'm able to do that is because it's symmetrical. If you graph these two curves, you'll see they're symmetric with the y-axis. So this is kind of a shortcut that I can do, particularly if I'm going to try to work this out by hand. And again, it's going to be y, or r squared minus little r squared, and then dx. The answer on this one turns out to be a very nice 32 pi. So a couple of comments here on this last one. I'd like you to think about what shape that might make if when we rotate that region around the x-axis. 32 pi. And then the other comment I would like to make is all three of these examples that I've done all were rotated vertically. They had a vertical rotation. Remember, these formulas can be applied to horizontal rotations as well. Have a good day.